Okay, let's start. Good afternoon, everyone. First, I want to tell you that uh, write here your name and the student ID, okay? For your attendance, okay? I will write it later by myself in the attendance sheet, okay? So make sure to remember writing your name and student ID here. Do you hear me?
Yes.
Yes. So let's start. Today we will solve. Just 1 second. Ah yes. Today we'll solve related rates problems, okay? First of all, you have these formulas. You may need them, okay? For example, area of a triangle, area of circle, area of sector of circle. Of a triangle, it's half BH, half times base times height. Circle, A equals pi r squared. R is the radius. For sector of circle, half r squared theta. Theta is the angle here, okay? You also have volume of a sphere, volume of cylinder, cone, these things. You will need some of these. Let's start with the first question. So we have the length of a rectangle is
Professor, will it be given in the exam?
related rates.
No, I mean in the midterm.
I'm not sure. You need to ask your professor about this. But I think you need to ask the professor. Now, the length of a rectangle is increasing at a rate of 8 centimeters per second, and its width is increasing at a rate of 3 centimeters per second. When the length is 20 centimeters and the width is 10 centimeters, how fast is the area of the rectangle increasing? So let's start writing this given information. So we have the length is L, okay, and the width is W. We are given that the length of the rectangle is increasing at a rate of 8 centimeters per second. So we have dl over dt equals 8 centimeters per second, right? We also have dw over dt remember to write your name, student ID, okay? Okay, let's continue. Now dw over dt equals 3 centimeters per second. Now when the length is 20 centimeters and the width is 10 centimeters, how fast is the area of the rectangle increasing? So we want to find what? We want to find the area, but let me show you the question. Uh, yes. So we want dA. A is the area, okay? So we want dA over dt when L equals 20 centimeters, W equals 10 centimeters. Now what's the area of rectangle?
200.
A equals LW, right? Now how to find the derivative of A equals LW? we differentiate with respect to t, right? With respect to time. So we have dA over dt equals L dw over dt plus w dl over dt. Good. Now, when now we want to find this when L equals 20 centimeters and W equals 10 centimeters. So let's substitute this. So we have dA over dt equals 20 times dW over dt is 3, okay? Remember, dW over dt is 3 and this one is dl. dl over dt is 8. dW over dt is 3. So 20 times 3 plus 10 times 8, right? So we have 60 plus 80 equals 140 centimeters squared per second, right? Yes, per second. Centimeters squared because it's area, and the unit for time is second in this question. Are you good with this? Do you have questions? Do you hear me? Okay, let's continue. Now the second question. Now, if a snowball melts so that its surface area decreases at a rate of 1 centimeter squared per minute, find the rate at which the diameter decreases when the diameter is 10 centimeters, okay? The diameter is x. Call it x, for example, okay? I don't want to use d. Why? Because I will use dd over dt. It's not good, right? So let's use x for diameter. But diameter equals what? Equals 2 times radius, okay? Remember this. Now let's write, you also can solve for r equals x over 2. We will need this. Now let's write the given information. We are given that the surface area decreases at a rate of 1 centimeters per minute, okay? So we have dA over dt. Because decreases, we put minus sign, okay? So minus 1 centimeters per squared per minute. Now find the rate at which the diameter decreases when the diameter is 10 centimeters. So we want dx over dt when x equals 10, right? Now what's the area of surface of ball? It's this one, right? A equals 4 by r squared. But I want x, the diameter. How to make it for x, the diameter? Instead of r, we substitute x over 2, right? So this here equals, remember that r equals x over 2. So we can write the area using x over 2. So we have 4 by x over 2 squared. So we have 4 by x squared over 4 equals by x squared. Are you good with this? Now I want you also to participate, okay? Who wants to participate and help me differentiating this with respect to t? Let's ask you one by one. Uh, Mar- Mariam, Mariam, do you hear me?
Yes, I hear you.
Yes. What's the derivative with respect to t for a? So we have,
With respect to t,
yes, we have dA over dt equals what?
wait, which one am I looking at?
Uh,
Okay, it's gonna be 2 pi
yes, 2 by
x.
dx over dt, right?
Yeah.
Thank you. Now, after Mariam, we have Yusuf. Yusuf, do you hear me?
Yep.
What's the next step here?
Um,
We want dx over dt at x equals 10.
yeah, so
So
we
yeah,
can equate d over dt to -1.
yes,
Yeah,
we, we substitute the given information, right?
yeah,
So we have minus 1 equals uh, 20 pi, because 2 times 10, x equals 10, 2 times 10 is 20, so 20 pi dx over dt. So we get dx over dt equals minus 1 over 20 pi centimeters per minute. Uh, yes, it's per minute in this one. Now let's go to question 3. Mira?
Yes.
Yes, let's see question 3 now. We have a kite 50 meters above the ground moves horizontally at a speed of 2 meters per second. At what rate is the angle between the string and the horizontal decreasing when 100 meters of string has been let out? So let me show you. So we have the kite here, somewhere here is flying horizontally, okay? So y is yes, y is the length. Here you have y, here you have x, okay? And here you have theta. The angle is theta. So y is the length of the string, x is the horizontal, 50 meters is the height, okay? So here let's write the given information. So we have moves horizontally at a speed of 2 meters per second. So we have given dx over dt equals 2 meters per second, right? Now we also have at what rate is the angle between the string and the horizontal decreasing when 100 meters of the string has been let out. So we want to find what? We want to find d theta over dt at y equals 100 meters, right? Now, what's a good formula for this? To connect this data, to connect x and theta. What do you think? Do you have idea about this?
Professor, is it Pythagoras theorem?
Here, Pythagoras theorem is not good enough, because you want something having theta. Pythagoras theorem.
Cosine.
You want to use cosine.
Yes. Adjacent over hypotenuse.
So cosine theta equals adjacent. Adjacent is x. So x over y hypotenuse, right? Now, but what is y? Yes, y is the length of the string. Now your idea is the hard one, but we will solve it to show you the hard method, this one, then the easier one. Okay, so let's start with this one. Now So we have cosine theta equals x over y. What's the derivative here? Negative sine theta
Sine.
d theta over dt, right? Equals, for this what will we use? The let's use the product rule for this x over y. I prefer product rule, okay? So we have 1 over y dx over dt. Then now the derivative of 1 over y times x. What is the derivative of 1 over y? Minus 1 over y squared dy over dt. So we will have minus x over y squared dy over dt. Good. Now what's the value of sine theta? We need sine theta in the, see here the derivative, it's minus sine theta, so we need sine theta. Sine theta equals what? Opposite over hypotenuse, right? So 50 over y. Let's substitute 50 over y in the derivative here. So we have minus 50 over y d theta over d, here d theta over dt equals, then this the same thing. Now now the hard part with this, with using cosine, that now you need to find x, right? X when y equals 100. How to find x? See the triangle? What will you use now to find the value of x? Pythagorean theorem, right? So let's use it. What's the Pythagorean theorem in this triangle here? What do you think? X squared plus 50 squared equals y squared, right? We have y equals 100 because we are working with y equals 100. So x squared equals 100 squared minus 50 squared. We move 50 squared to the other side, okay? Now the value of this is 7,500, okay? Are you good with this? So here x equals what? Equals 50 square root of 3. You can use calculator to find the exact value if you want, as you like. But I want to keep it like this. So we have the value of x now. What do we need more than this? So we have the value of x, we have the value of y, we have the value of dx over dt. So we still need the value of dy over dt, right? How to find the value of dy over dt? What do you think? We can find dy over dt using Pythagorean theorem, okay? Don't worry, this is the hard solution. I will give you easier one, but I need to show you this to know that you can solve using this if you want. So let me show you how to find the dy over dt. X squared plus 50 squared equals y squared. Now differentiate this equation. What's the derivative of 50 squared? 0, because it's constant. What's the derivative of x squared? It's 2x dx over dt equals 2y dy over dt. Now cancel 2 with 2 if you want, as you like. It's better to cancel it. We can cancel 2 with 2. Then we have, we just substitute the values. But let me first solve for dy over dt. So dy over dt equals x over y dx over dt, right? Are you good with this? Did you all write your names and student ID? Remember to write it, okay? And now let's substitute dy over dt in the equation. So here I will substitute dy over dt here. Good. So let's start. So we have this same thing, but instead of dy over dt, but this one, x over y. So x over y dx over dt. Are you good with this? When you multiply, what will you get? You will get x squared y cubed dx over dt. Now let's substitute all values. Good. Let's write the values. Y equals what? Y equals 100. X equals 50 square root of 3. We also have dx over dt. What is dx over dt? I will check it now. Dx over dt equals, yes, 2 meters per second. So equals 2. Let's substitute everything and simplify. So we have minus 50 over 100. d theta over dt is the unknown that we want to find. So d theta over dt equals 1 over 100 times dx, yes, it's 2, minus, now 50 squared to be 3 squared, it will be, just 1 second, yes, 50 squared to be 3 squared will be 7500 over y cubed. But what is y cubed? 100 cubed. What is 100 cubed? Million, right? 6 zeros. dx over dt is 2. Now you use calculator and you will get at the end, you will get, when you simplify all this using calculator, you will get d theta over dt. So first you calculate this and then you divide by this value. So you will get what? You will get minus 1 over 100 radians. The unit is radians, okay? Per seconds. Do you have questions? Are you good with this? Do you hear me?
Yes, yes, good.
Now the second solution, how to solve it? There is easier solution. We solved using the hard one to show you that you can solve it another way. So math, you can think and use another method. You can solve as you like. But there is easier method. I will show it to you now. So, but I will take the given information again. I think are they done? We need to write them again. So yes. Now what do you think? What is the easier method? Cotangent theta. If you use cotangent theta, it's very easy. Cotangent theta equals x over 50. Okay? You can also use tangent if you want. But tangent is harder. I will show you why. 50 over x. Which one is easier to differentiate? X over 50 or 50 over x? They are both easy, but x over 50 is easier, right? 50 over x, it will be minus 50 over x squared dx over dt. But x over 50, it will be just 1 over 50 dx over dt. So it's easier, right? So let's use cotangent theta. So cotangent theta is the easiest solution. Now, what's the derivative of cotangent theta? Umran, do you hear me? Saif? Muhammad? Okay, Yusuf.
Is it minus cosecant squared?
Yes, so minus cosecant squared theta d theta over dt equals what? 1 over 50 dx over dt. We need to find cosecant, right? What is cosecant? Cosecant theta equals what? Word? Okay, you can answer me.
I think it's 1 over sine.
Yes, 1 over sine, so it will be hypotenuse over over opposite, right? Y over
Yes.
y over 50. Thank you. Now y equals 100, so we get 2, right? Cosecant theta equals 2 when y equals 100. Let's substitute this value, these things. So you have when y equals 100, we get what? Substitute cosecant, you get minus 2 squared, which is minus 4, d theta over dt equals 1 over 50 dx over dt. What is dx over dt? It's 2 equals 1 over 25. Divide both sides by minus 4, you get d theta over dt equals minus 1 over 100 radians per minute. This solution is easier, right? Just a few steps. Now let's go to the next one. But
Wait,
before
Professor, I have a question.
yes.
How did you know to use cotangent?
You need to use something relating the given information. You want d theta over dt, to find d theta over dt when y equals 100, right? But you are given that dx over dt equals 2 meters. So you need formula relating this. You can use cosine as before, because cosine has theta and x, right? But it also has y, making it harder, right? So you can also use what also? You can also use sine theta if you want. But it will be also the same level as cosine theta of now. You can also use tangent, but which one is easier? Cotangent, because secant again, tangent theta equals 50 over x. So here when you differentiate, you will have minus 50 over x squared. So it's a little bit harder than cotangent theta. So you think about the best method. So you can use the trig functions, sine or cosine or tangent or cotangent. I think you can use also secant or cosecant, but there are ones that are easier. For example, as tan theta and cotangent theta, they are easier than the others, right? Is it good?
Yes, thank you.
Do you have another questions? Okay, let's continue. Now question 4. Question 4 is easier. You have the top of a ladder slides down a vertical wall at a rate of 0.15 meters per second. At the moment when the bottom of the ladder is 3 meters from the wall, it slides away from the wall at a rate of 0.2 meters per second. How long is the ladder? So we have, what is given here? We have the top of a ladder sliced down. Sliced down means it will be this y, right? Y is the height, the distance, the value here, right? So yes, you
So
can.
we have dx over dt equals 0.2. This is given.
Dx over dt equals 0.2
Yeah,
meters per second.
per second.
But
Yeah, and the
this will not
dy over d2 equals negative 0.15.
minus sign, right?
Yeah.
So dy over dt
Mhm.
equals minus 0.15 meters per second. Thank you. Now, so we have this given information. We have dx over dt at y equals 3, meters, 0.2 meters per second. dy over dt minus 0.15 meters per second. Now, what's next?
Can we say that x squared plus y squared equals L squared?
Yes, this is the formula we need. The Pythagorean theorem. So x squared plus y squared equals L squared. We can use it
And
because this one here is
yeah,
right angle.
and now we can differentiate. So it's gonna be 2x multiplied by dx over dt plus 2y multiplied by dy over dt. It equals 0.
Yes, thank you.
And
Now,
if we divide it by 2, we can remove the 2 from d2x and 2y.
and we can move one to the other side.
Yeah, and now we can substitute the values and we'll get y.
So when we substitute, but what is we have the value of y.
Mhm.
What is the value of
The,
x?
the x is 3.
No, x is not given.
Oh.
No, just 1 second.
No,
Uh,
bottom of the ladder is 3 meters from the wall.
yes, x is given.
Yes.
This is
Yeah, it's given.
x equals 3. We need y,
Yeah.
right? How to
Yeah, we
find?
need y, so we can just substitute the known values right now.
Yes, so we have y squared equals L squared minus x squared.
Yes.
We will get, when we substitute 3, we will get L squared
Uh,
minus 9.
yeah.
So
Yeah.
y equals square root of L squared minus 9. Next, we substitute all of these things. So we have x equals 3.
3. Yeah.
Dx 0.2.
Yeah.
So times 0.2 equals minus y, which is minus the square root of L squared minus 9. Dy over dt is just 1 second. I need more space. So let's go down. So here times minus 0.15 minus 0.15. Then we solve for L. So we have 0.6 equals, I will write it as if, so 6 over 10 equals 15 over 100 square root of L squared minus 9. Square both sides, you get 36 over 100 equals 15 squared is 225 over 10,000 L squared minus 9. Multiply both sides by 10,000 divided by 225, okay? And then you simplify. So you have
It's, in the end, I think we'll get y equals 4.
so you have 3 6 over 100 times 100 with 1000 is 100, right? So we have 3600 over 225. I will use calculator in a moment. Now L squared equals 9 plus this. 225, I mean. So it will be 5. L squared equals 9 plus 16.
It's 25 and L equals 5 meters in the end.
Yes. So L equals 5 meters. Now let's solve the last question now. But let me erase this here because I wrote it in the place of the new question. Now let's solve the last one. Now question 5, you have two people. You have two people start from the same point. So they started from here. Just 1 second. Where is it? Yes, it's here. So they started from here. Two people started from the same point. One walks east 4 kilometers per hour. So the first given information is what? We have dx over dt equals what? Equals 4 kilometers per hour, right? The other walks northeast, which is y, northeast at 2 kilometers per hour. So we have dy over dt equals what? 2 kilometers per hour. How fast is the distance? When we say northeast, it means the angle between them is 45 degrees, okay? So now, how fast is the distance between the people changing after 15 minutes? Which means we want dz over dt after 15 minutes. What is the meaning of this 15 minutes in terms of x and y? I mean, but before that, what's the formula relating this data? What do you think? Who wants to participate? Dana? Dana, Dania, Ghala, Maryam.
Professor, you can call me?
But I'm not sure what's the answer.
Uh, do you know which formula we will use to relate this data? We will use cosine rule, okay? Cosine's rule, which is we have z squared equals x squared plus y squared minus 2xy times the angle between cosine the angle between them, which is cosine 45 degrees. What is cosine 45 degrees? 1 over square root of 2. So we have x squared plus y squared minus 2 over square root of 2, which is square root of 2xy. Good. Now let's differentiate. Who wants to help me differentiating this with respect to t?
Could you repeat? I didn't understand.
This one here.
The last part, yeah, the 2x cosine 45.
Yeah, this is formula. You have this formula is called the cosine's rule. So here we are using the cosine's rule. Cosine's rule is similar to the Pythagorean theorem, but it's more general. because here see the angle is not 90 degrees, it's 45 degrees. But this is generalization. For example, if this is 90 degrees, then you have Pythagorean, because what is cosine 90? 0, right? So this formula is, we want z, right? We have the formula z squared equals x squared plus y squared, the other two sides of the triangle, minus 2 times these sides xy times cosine the angle between them, which is 45 degrees. Is it clear now? Are you good with this? Do you hear me?
Yes, yes, good.
Okay. Now the next step, you have 2 over square root of 2 is the square root of 2, right? Because 2 equals square root of 2 times the square root of 2. And you are dividing by square root of 2, so you have just 1 square root of 2. Now, who wants to differentiate this with respect to t with me? Tala?
Yes, Professor.
Let's differentiate this.
It will be 2x plus 2y.
Let's start with z squared.
2z equals
2z
2x
dz over
d
dt
equals to 2x dx over dt plus 2y dy over dt. And then this was product rule.
So let's open parentheses to make sure that we don't forget the minus square root 2. So xy x
Yeah.
dy over dt plus y
Plus
dx over
y
dt.
dy over dt.
Thank you. Now, Fatma.
Yes.
Yes. We need the values of x and y, right? And also z. When we want to substitute them to get dz over dt, right? We have just dx over dt and dy over dt. How to find x and y? What do you think?
I'm not really sure.
Okay, I will tell you. Is there someone who knows how to find it? Okay, I will show you. Now we have the time, right? After 15 minutes. And we have the velocity, right? So we can get x and y, which is the distance, right? So x equals what? Equals 4, which is dx over dt, times time, which is 15 minutes. But in hours, what is 15 minutes in hours? 1 over 4, right? Are you good with this? So equals what? 1 kilometers. Are you good with this? What is y? 2 times the time, 1 over 4. You get half. Are you good with this? Do you have questions? Did you all write your names and student ID?
No, bros. Thank you.
Now, what's the next step here? We will substitute everything in the in this formula, right? But just 1 second. X equals 1. Yes. So let's write them. We have x equals 1, y equals half. How to find z? Substitute in the formula of z squared, right? Which is this one. Let's find the z. So z. Rashid? You are joining at the end of the lecture. And there is Reem, I think. Why are you late? Reem and Rashid. Now, z squared equals what? Equals 1. 1 squared is 1, plus 1 half squared is 1 over 4, minus 2 times xy. No, I'm using this one, square root of 2 times xy. So, square root of 2 times 1 times half. So, this equals what? I will simplify. Equals 5, the constant's 5 over 4. Then, this part is 1 over square root of 2. Okay. Let me write this. 5 over 4 minus 1 over square root of, just 1 second. Good. Now next step we find z. So z is 5 square root of 2 minus 4 over 4 square root of 2. Are you good with this? Next we substitute everything. So the formula is dz over dt. dz over dt equals this divided by 2z. You divide by 2z to make it dz over dt. You substitute everything and you use your calculator. You will get 4.3 kilometers per hour. Are you good with this? Yes, no.
Professor, are you going to be posting these on iLearn later?
I will upload the video. I will
Okay,
send you the link of the video.
Okay.
Do you have another questions? Make sure to write your name and student ID. Reem, you joined lately, right?
Yeah.
We write it again.
No, no need to write it again. Just make sure if you wrote it. Let's see again. So we have Mariam, Mira, Yusuf, Rashid. Why were you late? And Reem, you need to join from the start to to be considered that you attended. Okay? Do you have reason?
Doctor, I thought it would be on class collaborate. I didn't see the link on announcement.
Okay. What about Reem?
Yeah, same. I didn't see the link.
Okay. Now we'll stop here. I will write your names in the attendance sheet and put it on iLearn. Okay. So so if I didn't write your name and you attended, you can tell me. Okay. But here I'm saying all names. Okay. Now let's stop here. Have a nice day.
Thank you, Professor.
Welcome.
Thank you.
Yeah,
So.